Good evening once again. Class hours si ako'y mamang the laws of motion loy gre theory ta kre question loy hot kre jing na si work energy power to gudun ni ko. So ma'am sir nangang si tabra yes no hero tabra.
Tai sir.
Tai ko. Okay fine. Lakshmi tabra Lakshmi Sunanda tabra.
Tai sir.
Okay fine. Yeah. Adu gadi class hours si ko. So today we'll do work energy power ko. So muna tao kang the yar gadi sir dum hango. Not an issue. So class hours. All right. So work, energy, and power. Now, the first and foremost definition of work is harga work si kay oy ha matamda work done haigera work haigera ka. So work done W is equal to harga F ka force into displacement hai ka F dot S hai. So actually mazi it is the dot product of F force vector and displacement vector never ka adun F dot S and high never ka. Or you may find dw is equal to F dot ds, or you may find w is equal to integration of F dot ds, kind of a different form the thambay icon. So all these are definition of work done. What is the takeaway? Work done have first and foremost work done have scalar money. Aduga ay ngatang recording si post toge aduga no ito kainom hangge. Just a second. Recording po? No, recording ngatang post toge ka. Okay, fine. Recording in progress ka. All right, fine. So matik ang masigi tat krene to isang sum na diya ka. Anyway, fine. So okay, is work energy power ka. Si matang diamond. So the first definition of work done is it is the dot product of force and displacement vector. Yare. So aduna again, you may also write W is equal to F into S into cos theta na ko. So Fs cos theta direct hai ko. F S cos theta na ko. Aduna kaidong have the aina force ka displacement ka kayuma perpendicular oina raba. Adu work kem ta tawdeba. Sisi manoy khanggadaba. Yan dai ko aja. Aduna habidi nangna kaygumba ground dagi object amazi kaygum mathata pukhaleng khalajeba ko adu ergadi displacement di kaino up taneba, and this is the direction of displacement. And what is the direction of force? The direction of force na downward ta kaino di force weight ni dana ko on F is equal to kaino mz neba, and magi direction di kaino downward ta leba aduna adu ergadi theta zi 180 degree lani aduna minus lani aduna work done do negative oirani bako aduga adugi work done do again potential energy and store to work khotpa kona lakani. So aduan lakaduni aduna sarna haning is kaino habada karigumba nang na sigi ball si sidagi na sibo puren khalaje soibo adu magi weight ti my weight ti kaino my weight is downward never weight has force to nika aduna downward and displacement in direction is from the salaba on a perpendicular have the work done 0 taneba. Kainodi Fs cos theta and theta cannot be 90 degree. If theta is 90 degree, work done is equal to 0. Yareka. So and then akoi sigi definition of work done je pan be adaba situation mayamam tholakani bu ko. Akoina yamuna tau ko. Akoina kai khangi have the akoina ziki loss of motion we have the first law, second law, third law, the external force the velocity constant o and high first law motion high see if the net external force is 0, the velocity remains constant. Aduga we have the body magi velocity change or my momentum change or adu rate of change of momentum do external force applied to the money in high aduna kaidongi ha matamda for example any mass amazimagi some initial velocity na chalameba, but after a while my velocity is change tawreba adugidi adugi du kai dongni ha matamda velocity change torom ni na magi energy change tawre ni ko kinetic energy change tor kon la kadoi ni kamai la kadoi na we'll see that later, but magi kai do we have the force amana work khara tawdragadi body amasi my velocity si masa mathanda change to ngam jade ba ko change to ya de ba masa mathanda force amana kai gumba work to da ba taragadi yai ko aduna kai do we have matamda akoina aduna adugi matang du ko work done puto ke hargadi force ko chi bidi phangoi ba kai force piram moi force locate to ngam moi ba ko calculate to ngam moi aduna adum kan the work done ji kamai puto ke ne the work energy theorem dagi to ba ne ba ko, so we will see that. Now this is the first definition of work done. The second definition of work done ji akoina kai hai matamda work done W is equal to Kf minus Ki hai ba ko, and K stands for kinetic energy. So Kf stands for final kinetic energy, Ki stands for initial kinetic energy. Auna sigi sina hena maru oi ba ko. Sisu maru oi, but sisu ya maru oi ba ko. This is work energy theorem. Si kamai la ino have the hypertroph ma haram ge akoina kedo we have the ziki kinematic equation ki third subudo. Kaino do v square minus u square b square minus u square is equal to twice as and lay ko lay line hen jan jong tore tois yare ko ni biasing si haw yam thing aduna si is ina kai gumba half m na multiply to buta aragadi b square minus u square sida adudi half m na multiply to buta aragadi 2as 2 ga 2 ga kre ko adi koina newton gi second lo gi akoina derivation akoina derive to do ma di force ka manadra auna f into s layer sida s ko ina hapsa do line na hete yoksula ko ni tais ko aduga kai lay habda som side na half m v square minus half m u square leba adi aina kai khangi habda f into s di work done neba au this is the aina kai nen loksula ne habda this is kinetic energy final minus kinetic energy initial kai ino sa hete loksula ije ha matamda akoina kai khangi habda work done ga energy ga se same dimension lay same kai ni unit lay ko loina joules so only work done work khara tawrakanda body ma energy change la eba ko aduna work done and energy si equivalent oeba amana amagi equivalent oeba work done ga energy ga auna right hand side ta ina work done gi dimension phangam ni work done taram ni som side chu work done ga manaba amadi tabam thokane ba adu sidadi the work done which is associated with velocity sida v u all these are velocities and v is in a final velocity ni u is in a initial velocity ni adu ergadi work done ga manaba physical quantity n adu ju kai doba haidi work done ga mana physical quantity si energy khatang ne ba energy na tan leite ba auna energy du da velocity ga associate tawram ni na kinetic energy harni v ga associate tawram final kinetic energy u du na initial kinetic energy, so kf minus ki is equal to w hai si kai de la ino ha ba da koi gi kinematic equation third su do adu da gi si la ine ba ko, so si si me am loina gyan ta ba ngambra ngami ko ngambra
sir.
ngami so aduna sigi formula si am powerful oiba work done har ga force into displacement or dot product of force and displacement high gnuba habdi adu katang na teba adu di am limited oiba definition ne ba ko work done har the change in kinetic energy have that si su yam important oi aduna si is always keep to gnu ko si ne hen fazai ba si da gi di si ne fazai ba ko adu gini, so this is work done yare ko. Then question amani hochi aduga ai sir na noida conservative force kaino then potential energy kaino aduna chingudu hairake adu sigi sida koina point amaga hapsan over yai kai hapsan over yai ha matamda kinetic energy have si kaino habda kinetic energy is equal to half m v square na if the aduna half m v square si kinetic energy tare ko aduna kinetic ko sigi se that's okay. And kinetic energy K is equal to half m v square ko. So sigi ahumzi sigi sidagi akoina khangba ngame ko. Anyway, C is equal is log thoge. aduga question amani hotsi. Now question number 1 yung ko work energy power ge 2016 na noi gi da 2016 ni matung da hangba question soidam ki yoram ni adu da noi na lui na khalla gadi sir da whatsapp da photo ka pa thar pe yani ko sir haji dum holake adu yengo yawbre ngo aduga sir na already no der hide diagram ko just a second see the layer ko na is it this yes one mangi ko ai sisi aina promoter win to it ihe I'm sorry kaide kakra wina jikita where is it yes no yes yare ko so sir na haji haining is ko stop share to ge yang ko sida CD promoter wudi na te do sigi like si keno noi lo ne ma lai gedam ni Lakshmi ga Sanjana ga su lai bra si like sa Lakshmi ga ha keba Lakshmi and Sunanda lai ko lai ba si lai gedam ni adu sigi question jing jin report gedam ni PYQ ma'am ji sigi like na ko phajab ni PYQ da ari han kai kama mazu lai but yam kan phajaboi de si yam phajai si holu tawgadabu magi maning solution aran ma myam yawbane aduna adugi matang du sir dum ha ke kai da kai lali have the ko but see question je I highly sigi like see I highly recommend it ko sir ne am recommend to jabal like amani so kai no you cannot minimize okay fine so adu bitaragadi makata orzi aduna sigi sida noina jike do work energy power gi da 37 years kinina soidam ki anova question soidam ki yoram mani ko so adudu yengo aduga noina khangoi gumba yauragadi sir da haro photo kapaga or sir da hairasu ai sir na kapaga adum solve to ri yadi yare so yaude 2016 lei ko tai late anyway solve to okay, fine. So, see the height, a particle moves so that its position vector is given by this, where omega is a constant. Which of the following is true? And I have a do this equation Z. I get dry here, draw. So, them solve the aurora. Now, CGCD, noina kedoba circular motion giving R vector is equal to cos omega t cos omega t I kept her but man x kept in hierarchy m kai de cos omega t x cap plus sin omega t y cap tare ba so adu regadi sigi cd magi cc position vector ne ko si sa now sigumba si koina kai dagi law ne amatam da circular motion ne sigumba si yan dai kai ja circular motion oi gedini auna sidai sida cc r vector ni and cc na theta or phi is equal to omega t harsu yai and then magi component ai magi coordinate sing do amana kaino habda r cos omega t warni amana r sin omega t warni cc gyan tai ko auna magi cc na x cap ni I cap harsu yai cc na j cap ni or y cap harsu yai adu regadi sigumba vector zibu kaina C-Subu, we have the C position vector name, which is a cos. So, a particle moves so the its position vector is given by this, where omega is a constant. Omega is a constant, or the constant angular velocity maintained. So, velocity is perpendicular to r. Yes, velocity is perpendicular to r. The velocity vector has always tangential wave. The velocity is r vector is perpendicular always. The velocity is perpendicular to r. Has aduga okay, and acceleration is directed towards the origin. Yes, acceleration the always circular motion the acceleration is centripetal way towards the origin ko kay no ma tangentially pai bu chingjan bagi tension nam na ching bagi tension na is force ni acceleration ji ju mass into toksela di force on doi ni aduna tangentially pai thoki ga da po to in zum chingjan ba towards the center at every instant tum chingchala ma di circular path am the sarhali ne ba ko aduna the first option A is correct but atai su yeng si velocity is perpendicular to RC to acceleration is directed away from origin ko si directed away si lale auna si lale then velocity and acceleration both are perpendicular to R velocity with the r the perpendicular or acceleration the r the kedoba anti parallel wave ko aduna perpendicular di oite aduna si lale The velocity and acceleration both are parallel to r. Sisulale acceleration is not parallel to r. It is anti-parallel, and velocity the parallel or the velocity the perpendicular way. Gadam ne buka. Aduna sisulale. So lan bay maram yam si loina makhang bra banoi loina magyan ta ho bra.
Ta ho sir.
Ho buka. Okay, fine. Can you dita ho bro? Nivya, Sanjana, Niha.
Oh sir. Ta sir.
Okay, fine. Sanjana di library le Kumara. Anyway, fine. Right. Question number 2. If vectors A vector and C layer, B vector and C layer are functions of time, then the value of t at which they are orthogonal to it. Orthogonal have the perpendicular oiba have a so vector and perpendicular oi dizzy kai don't dot product log 0 target the perpendicular oi hide neighbor. Kai you know have matam da dot product the vector A ga vector B ga dot product have C kai no the A B cos theta neighbor. Other theta to 90 or the queen kai hang the cos 90 di kai no cos 90 is 0 never. And dot product 0 targa di vector and the perpendicular oi higher than never ko. So see knowledge equine season araga. Question number 2 zino in asana to bungam gadra sharedum to zira. Hero. Question number 2
Sir try to.
Try to give ko. Okay. So to ado niha nivya Sanjana hero noidi. Yado man bra sir to honing bra.
Sir to sir.
Sir to za. Okay. Alright, fine. So if vectors A and B are functions of time, okay, then the value of t at which they are orthogonal to each other. Yam live upon in the city. See me on the Oh no, aina kai the way I have the A vector dot B vector is equal to hierarchy cos omega t by 2 plus sine omega t sine omega t by 2. Noi si dot product lo with that noi khangi ko a vector si let's say a1 I cap plus a2 j cap ne khalaje b vector jina kai b1 I cap plus b2 j cap ne khalaje adu regadi a dot b ji kai tani a dot b si a1 b1 plus a2 b2 taiba adu khangi ko adu ne ji palise adu taragadi sidi kaino habda noina trigonometry gida cos a minus b tawudo adu tarani auna cos of a minus b ko so si ngorba aduna cos a minus b di cos a cos b plus sin a sin b ni dana ko now sisi kaigumba 0 oiba taragadi kaino hai matamda omega t minus omega t by 2 should be equal to pi by 2 natragana odd multiples of pi by 2 har si ai kem kai de. But CGC we only have that this is half omega t is equal to pi by 2. 2 cancel sakre. Aduna t is equal to pi by omega. So option A is the right answer. Ngau brasi se. Gyan tabri yung. Gyan tada step yauri sir CG step si gyan tada na hero ko.
Tai sir.
Tai ni hata hai.
Tai sir.
Ni hata hai. Lakshmi ga Sunanda ga di tarba.
Oh, tai sir.
Okay, great. Let's proceed. So question number 3, if vector this is perpendicular to this vector, then the value of alpha. See, no, idum dot product law 0 put to law aduga adum taza adu di yone. See ban see what does you have 8 alpha learning go 4 to 8 4 3 12. 8 minus 12 minus 4 minus 4 does some pugradi plus 4 4 day nearly half. So correct answer is A option A tarn. Hajik du gyan ta bra am thuman bra. Gyan ta ngam bra.
Tai sir.
Okay, fine. No, tay julo ni mangam gadra question number 3 ja.
Oh, sir.
Okay, fine. Question number 4G, on the vector sum of two forces is perpendicular to their vector differences. In that case, the forces are. Question number 4G, Hydra.
Hey, sir.
Kennedy Lakshmiga, Sunandagati, and
Equal to each other.
the vector sum of two forces is perpendicular to their vector differences. In that case, they are equal to each other. Okay, now, kayo ini have the okay, do this torage ko. Sum वर्ग root over kaino a square plus b square plus twice ab cos theta. Sum vector sum vector difference na kay a square plus b square minus twice ab cos theta. Yare ko aduri kay dawni have the 4ab cos theta is equal to 0 tare ko. Aduri theta is equal to pi by 2. Natro ay ngay ko ay pamisi kay no. C square root ka a square plus b square ka 2ab cos theta equal to minus 2ab cos theta. Adu 2ab ka adu cos theta is equal to minus cos theta na chatle angle lom na chat kre ko. 1 second. The vector sum of two forces, okay, is perpendicular to their vector differences. Okay, perpendicular we have ko. Adu ibata arga di perpendicular o ibata arga di kay tarne. Perpendicular with C terms, this will be equal to 0 and this will be equal
to each other in magnitude.
Aduna, we only have the C and EC, was 0 sacreduna, C root over a square b square, they are equal to each other. Vector and is equal katang oiraga muigi vector sum do the vector sum of two forces is perpendicular to their vector differences haibane ko aduna sigi pochi sumaino ni yeng asi koina ko graph ki through the yoni yeng asi. Let's say I have a vector like this ko adudi sumaina ko parallelogram lo palo aduga sigi vector sum haimatam da. Let's say this is vector A and let's say this is vector B. Yare ko vector A ga B ga sum ni si tarne. This is A plus B never. This is A plus B. Kay no di nang na sida B lausalo GI, sida A lausalo GI, aduga na A plus B pang niba. Now A minus B di kay no have the A minus B di sumay lani. So this is A vector minus B vector provided this is vector A and this is vector B. Yare ko. Adu ergadi kay no have the vector and easy kay doni have the parallelogram amagi diagonal and easy karam kanda equal or kani. Sorry. The vector sum of two forces is perpendicular to their vector differences. Have an ko. Auna always the parallelogram khuding magta diagonals is always perpendicular oibra oidabra. Oini have a late ko. Libra late. Karam kanda perpendicular or kani kangbra. Rhombus or kanda oiniba. In every rhombus, the two parallelograms intersect each other at 90 degrees. Kangbra do dahana.
Sir. Khangi, sir.
Rhombus oidradi yadeba. Auna kaidoni have matamda are equal to each other in magnitude, are not equal, are equal to each other in magnitude. Haigadaba. Ka vector A ga vector B ga do are equal to each other in magnitude. Haigadaba. Kaigino di kaidoba haidi kahani rhombus oigadaba. Rhombus. Kahani rhombus da kaidoba diagonals. Diagonals kaidoba diagonals are perpendicular, and the diagonals represent the sum and the difference ko adugi concept to pan gadam ni on isi case lo thokrage gyan noi ta hoigo jikida
Sir.
Okay, so question number 5, the position vector of a particle is this, the velocity of the particle is a Sidi kaino ngasai a cos omega t a sin omega t adu this is circular motion tare ko auna directed towards the origin tare si dum chume auna option a sidi holurege khangobra si kise yadra yani ko r haidi r something haidi this a is in a kaino oiduneba a is in radius to oiduneba r is in a position vector neba auna a cos omega t is in a magi x coordinate to abscissa x abscissa so haibedo ko x coordinate haidi aduga y gi ordinate tuna a sin omega t zo idune ko duna x I cap plus y j cap gumba duni the cos omega t ko a sina magi ngasai gi radius to tare natragana magi position vector gi ngasai gi magi asang do tare aduna adugumba du circular motion ni and the acceleration the velocity of the particle oh sorry the velocity of the particle have ni ko sina position vector the velocity is not directed towards the origin directed away from origin no parallel to the position vector no perpendicular to the position vector perpendicular
Perpendicular.
ta ga ko aina acceleration gi wakan khal riam si jong mitta adion exam so idine je velocity have ne ba perpendicular to the position vector ha ba yani ko pa phone ko sana ja
Sir.
okay fine great now question number 6 the angle between the two vectors asi putho ac angles haigadra hairoidra sartarora dot product lowro aduga kai tage 0 taramani so jam ke 90 degree taramani 3 into 3 9 natra 4 into 4 16 natra 16 plus 9 25 natra minus 5 into 5 t minus 25 so to plus 25 ka minus 25 is 0 adun takpadi they are perpendicular so 90 degree haziki to gyan taubra
Also.
tai nibia
Sir.
okay lakshmi ga sunanda ga su tare haire nibia di tabra
Sir.
Great. Now, notions of work and kinetic energy, the work energy theorem. Consider a drop of rainwater having mass 1 gram falling from a height of 1 kilometer. It hits the ground with a speed of 50 meter per second. Take z constant with a value of 10 meter per second square. The work done by the gravitational force and the resistive force of air is I see question ali tawzi. Auna sige sida kaino sida tawzi have the 1 gram falling from a height of 1 kilometer. 1 kilometer dagi tarakadini ko. My mass in a 1 gram. Okay. It hits the ground with a speed of v. V pyramid v is equal to 50 meter per second. Now, the work done by the gravitational force. Work done by the gravitational force have work done by the resistive force of air. The friction work done by friction. So it's a very simple question. Work done by gravitational force haragadi kaitani khangbra sigise. So now gravity na to work ti kay I have the mgh star ni ko work done by gravitational force say mgh star gadini. So mg into h which is equal to haraga m di kay 1 gram di 1 into 10 to the power minus 3. And then z di 10 and then h di 1 kilometer or di 10 to the power 3 which is equal to 10 joules star. Very good. Very good 10 joules star. Mathang the work done by friction. Now work done by friction magi kinetic energy is half mv square minus sarga magi potential energy 10 joules subtract over do so tarakani sorry 10 joules subtract over kaino di friction na khara keno togreba negative maje aseng 10 joules la yebam di thoksabane ba ko 10 joules la soidam ki yeram aroiba friction na ka taptha lam mani ba ko auna 10 minus haraga half mv square d half into m d1 into v square d kaino v is 50 natra 50 into 50 so the 2 into 25 so 25 50 kaino 10 minus 125 okay something is not right mass kaino 10 to the power minus 3 ni ko ai dum sorry so do you get the a sumana ige mass
minus 8.7 ka.
mass in 1 by 1000 here again into 15 yung ko 1 then into 50 into 50 sumale ko 0 ni le 0 ngo 0 ngo sakre ko the sig 2 zidi c2 zedum lai sai c2 zedum lai so 0 ni sakre ko then 5 to 10 tare ko adu di kai tani have the ai am tanga e ge samdi am samning edu am tanga e ge si tare 10 for 40 40 minus this di no 35 35 by 4 adu gadi kaino habda 8 for 32 so 30 leme ka 32 gadi point number 30 adu di 7 for 28 for 8.75 tare ka so now masisi kai weni ha matamda kai 10 ga 8.75 ka pawazi kai tare option number C je tarba tare ka amana 10 joules amana 8.75 joules now C negative or si kai gino hai matam da masai mana phaba mana tapthan banina ko magi work done je negative point ni ba gyan ta right sa adu noina sumaina khanda bidane sumai aduain khallaga negative point ni na khallasu ya natragana work done is the final energy minus initial energy. So final to the half mv square ni initial to the magi kinetic like the potential do ni ani subtract to matam de so ni negative thola kani ko adu do na friction do negative o in higher zu yai but na chagana dum sida dum sigi work done the friction is always negative ne ko adu na do ina ko ina khala zu yai so this has to be negative yare ko adu na option C is the right answer ma'am lo ni mag gyan ta over sigi se Sunanda, Lakshmi, Neha, Nivya, Sanjana, lo gyan ta ubra?
Oh, tayo sir. Tayo sir.
Okay. All right. Question number 8. A particle of mass 10 gram moves along a circle of radius 6.4 centimeter with a constant tangential acceleration. What is the magnitude of this acceleration if the kinetic energy of the particle becomes this by the end of the second revolution after the beginning of the motion and height? So, see, sinuing amgadra, sardato honing brang amgadra, hiro. Yam kuina post lai roisi kok. Question pa bagi matam lau budi lau aduga hairo sarna tauzira noina dum nasana ngamgadra. Question number 8. Sanjana cheta khumazu ai ko nang library da leibani na. Cheta gi khumazu ai. Peba hot seba. Hajiki to tahudre. Hot pio hairo. Hot.
Oh.
Okay. Yeah. Hot. All right. So muna. A particle of mass 10 gram moves along a circle of radius 6.4 centimeter with a constant tangential acceleration. Okay. All right. So, what is the magnitude? So, my tangential the acceleration yes, according to uniform circular motion, the magi velocity c change laibanina akoina acceleration laibudi haiba adu direction change tawbagi ko adu katang natabida magi 마지는 시디 유니폼 circular motion 나테바 시디 양칼레바 겐다브라 숨숨 양칼라카도이네바 umba지 aduna tangential acceleration ju leiba centripetal di leitaba sumya yaroi kaigino di centripetal acceleration leitraga di uniform circular motion adi circular motion oiroi in the first place centripetal budi layani ba but tangential amaju leiba si question di da noina section da doise ko auna tangential acceleration hargadi sumsum yankalamani ba magi and what is the magnitude of this acceleration if the kinetic energy of the particle becomes equal to this by the end of second revolution after the motion has begun or after the beginning of the motion happening? Initial tangential velocity though initial velocity is zero never. Yeah, and then final do the final do the kang de final do the I kang de but kai di kangi half mb square di kang half mb square man pyramid 8 into 10 to the power minus 4 joules and pyramid. Now mass pyramid ko aduna aina velocity si kaino hay matamda 2 into 8 into 10 to the power minus 4 divided by mass kaino 10 gram 10 into 10 to the power minus 3 adu ay pataragadi kay torni habda 8 to 16 cos. So this is v square. The v is equal to 8 to 16 16 square root 4 tarni aduga sigi 10 to the power minus 3 mathak kakaladi kaino mathak kakaladi plus 3 on a minus 1 is 10 square tani 4 by 10 of the 0.4 tare ko on a 0.4 on a velocity is 0.4 meter per second tare sisi noi ngor mani to is ngor bagyan tadraba 100 ki square root 10 idana ko adugi okay fine so I is the velocity khange aduna kai do ya ne ja what is the magnitude of this acceleration put away it is so simple the acceleration we know 2as is equal to v square minus u square I kusam je kedo ya matamda line ong ching thokre line ong ching thokra me kedo ne na ja e dang e ne e dang e ga 2as na e ne and v di 0.4 into 0.4 2s s the circumference to circumference to second revolution have ni ko second revolution have ni ko on the second revolution hargadi 2 pi r do 2 into 2 pi r di r piram da 6.4 centimeter on a 6.4 into 10 to the power minus 2 le ko si myam je hot ka doini so yam no my number di note but still we'll do it so 4 si ko natraga se sumain to giro si audisi in a 4 into 4 into 2 into 2 j 4 harge and then pi c in a 3.14 harge then c 64 harge aduga c 10 to the power 2 na mathaka kalage 0.4 anigi makhada ina 100 10 square hapage 6.4 gi ina mathakta 10 am hapage so c ga kakre and then 4 amga kakre then 4 amana sida already 16 tare aduragadi masidi aina kedoni have the 10 the 16 348 na divide to bugumbani 10 the 48 na divide to bugumbani to 0 of the 100 to 48 to already 2 to matam na 90 ga 6 ta ani so obviously 0.2 gi something 0.2 something ta ani ko so sumaina ta ani hajikido gyan ta obra me amlone ma ngawbra
Gyan sir.
Yantai ko. So this is approximately equal to 0.2 meter per second square. So now let's proceed ko. Say question number 8 na tra. Question number 8 ki si kay taging si answers. Ay kang de answers. Question number 8 option number C. Question number 8 question number 8 option number C tayo 0.1 tayo kay question number 8 option number C tayo ko. ꯑꯗꯨꯗꯤ ꯑꯩꯈꯣꯏꯁꯤ ꯂꯥꯜꯂꯦ ꯀꯥꯏꯅ ꯑꯃ ꯂꯥꯜꯂꯦ ꯑꯩꯁꯨ ꯍꯥꯏꯗꯤ ꯍꯧꯖꯤꯛꯀꯤꯗꯣ ꯆꯦꯛ ꯇꯧꯅꯤꯡꯕ ꯍꯥꯏꯇꯥꯔꯦ ꯑꯗꯨꯒꯤꯅꯤꯀꯣ question number 8 option number C 0.1 ꯇꯥꯏ so let's do it once again ꯀꯥꯏꯗ ꯀꯩꯅꯣꯝꯗꯤ ꯁꯣꯏꯔꯦ ꯀꯥꯏ ꯁꯣꯏꯅ ꯌꯦꯡꯁꯤ velocityꯕꯨꯗꯤ ꯆꯨꯝꯃꯦ velocity v square minus u square okay twice 2 pi r Okay, fine. So 3.14. 3.14 ꯒꯤ ꯃꯇꯨꯡ 22/7 ꯇꯧꯖꯔꯥ ꯑꯗꯨ ꯀꯥꯟꯗꯦ ꯑꯗꯨꯕꯨꯗꯤ ꯑꯩꯅ 3.14 ꯁꯦ ꯁꯤꯒꯤ 0.14 ꯁꯦ ꯑꯩꯅ ꯀꯩꯅꯣ ꯇꯧꯁꯟꯗ꯭ꯔꯕꯅꯦꯕ ꯂꯧꯈꯤꯗ꯭ꯔꯕꯅꯦꯕꯀꯣ ꯁꯤꯁꯨ ꯑꯃꯨꯛ ꯂꯧꯔꯒꯕꯨꯗꯤ ꯄꯣꯠꯁꯦ ꯑꯃꯨꯛ ꯍꯦꯟꯅ ꯄꯤꯛꯊꯔꯛꯀꯗꯣꯏꯅꯤ 0.2 ꯗꯩꯀꯣ ꯁꯤꯒꯨꯝꯕ ꯀ꯭ꯋꯦꯁꯟꯁꯤ ꯁꯔ ꯀꯩꯁꯨꯝꯇ ꯀꯩꯅꯣ ꯇꯧꯗꯦ ꯑꯦꯄ꯭ꯔꯤꯁꯤꯌꯦꯠ ꯇꯧꯗꯦꯀꯣ ꯀꯩꯒꯤꯅꯣꯗꯤ ꯁꯤꯗ ꯍꯪꯉꯤꯁꯤ ꯐꯤꯖꯤꯛꯁ ꯈꯪꯕ ꯈꯪꯗꯕꯗ ꯆꯦꯛ ꯇꯧꯗ꯭ꯔꯦ ꯁꯤꯗꯤ ꯀꯩ ꯍꯥꯏꯅꯤ ꯁꯤꯗꯤ ꯀꯦꯜꯀꯨꯂꯦꯇꯔꯅ ꯍꯣꯠꯄ ꯌꯥꯕ ꯄ꯭ꯔꯣꯕ꯭ꯂꯦꯝꯅꯦꯕꯀꯣ ꯑꯗꯨꯕꯨ from the mathematical point of view ꯑꯉꯥꯡꯁꯤ ꯁ꯭ꯄꯤꯠ ꯍꯥꯏꯗꯤ ꯂꯩꯇꯦ ꯍꯩꯇꯦ ꯍꯥꯏꯕꯗꯣ ꯑꯗꯨ ꯌꯦꯡꯅꯕꯒꯤ ꯑꯣꯏꯅ ꯈꯜꯂꯒꯕꯨꯗꯤ ꯐꯕ sorry anyway I'll solve it don't worry lꯧꯊꯣꯛꯀꯦ ꯈꯜꯂꯤꯕ ꯄꯣꯠꯁꯤꯅ ꯁꯨꯡꯊꯣꯛ ꯊꯣꯛꯂꯛꯇꯕ anyway fine so ꯇꯧꯔꯁꯤꯀꯣ ꯑꯗꯨꯗꯤ ꯃꯁꯤꯒꯤꯁꯦ ꯑꯩ 3.14 ꯁꯤ ꯇꯜꯂꯦ ꯑꯗꯨꯅ ꯑꯩꯅ ꯀꯩꯗꯧꯅꯤ ꯍꯥꯏꯕꯗ 22/7 ꯑꯣꯏꯅ ꯇꯧꯔꯒꯦ ꯑꯗꯨꯗꯤ 72ꯗ something ꯀꯣ ꯀꯩꯗꯧꯕ sorry 72 ꯅꯠꯇꯦ 70ꯗ ꯀꯅꯥꯅ ꯌꯦꯟꯗꯣꯏꯕ 22 into 16 ꯅꯀꯣ so ꯑꯗꯨꯗꯤ 6 to 12 ꯑꯗꯨꯗꯤ 6 to 12 13 14 15 then 2 1 2 3 352 ꯅ ꯌꯦꯟꯗꯣꯏꯕꯀꯣ ꯑꯗꯨ 0 point ꯍꯥꯏ 0 ꯑꯃꯅ ꯑꯃꯨꯛ ꯑꯗꯨꯗꯤ 1 ꯆꯠꯂ 2 ꯅ ꯆꯠꯂꯗꯤ ꯍꯦꯟꯗꯣꯛꯈ꯭ꯔꯦꯅ 1 ꯅ ꯆꯠꯄ ꯃꯇꯝꯗ 352 ꯇꯥꯔꯦ then ꯑꯗꯨ ꯑꯣꯏꯔꯒꯗꯤ 10 minus 2 ꯗꯤ 8 then 9 minus 5 ꯗꯤ 4 then 6 minus 3 ꯗꯤ 3 ꯀꯣ so 348 ꯇꯥꯔꯦ ꯀꯣ ꯑꯗꯨꯅ point ꯑꯃ 0 ꯑꯃꯨꯛ ꯂꯥꯛꯑꯅꯤ ꯑꯗꯨꯅ 0.15 ꯆꯠꯄ ꯌꯥꯒꯗ꯭ꯔꯥ 5 3 15 352 ꯑꯗꯨꯅ even 8 9 ꯐꯥꯎꯕ ꯆꯠꯄ ꯌꯥꯔꯅꯤ 0.2 ꯃꯌꯥꯗꯤ ꯇꯥꯏꯌꯦꯕꯀꯣ somewhere ꯀꯥꯏꯗꯅꯣꯝꯗꯤ ꯁꯣꯏꯔꯦ ꯑꯩꯈꯣꯏꯒꯤꯁꯦ ꯑꯩꯈꯣꯏꯒꯤ ꯍꯥꯏꯗꯤ ꯁꯣꯏꯔꯦꯔꯥ ꯀꯩꯅꯣ ꯌꯦꯡꯁꯤ ꯑꯃꯇꯪ half mv square is equal to 8 into question amtanga paayeko a particle of mass 10 grams along circle radius with a constant what is the magnitude of this if the kinetic energy of the particle becomes equal to this okay tangential acceleration v puthoi v dagi aina omega v dagi equal to omega r adudagi aina tawba yade asumai puthokadam nate aina tawise chummi kem kaide auna sida tadisi kaino sinka something can this way now let's see moi comments of the things question number 8 natra aina kai swerba chamane moi to is 8 oh moi gi kaino change in kinetic energy okay fine so work done by all forces work done by tangential work done by centripetal is equal to change in kinetic energy adudagi di moina tangential acceleration puthoke haragadi kinetic energy final kinetic energy initial budi 0 lerna ko adududa kaina yenba adududa work done by okay 4 pi r na yenba ko okay so 4 pi r see kaino ne ko mass into 4 pi r 2 pi r 2 into 2 pi r is distance ne ko distance is the m kaino aduba ultimately moi taraisi kaino habda sidi chap manai mathakta 8 tarakpasine ko kinetic energy kenai je aigina kai tarakpa aigina 4 16 tarakpa ko 2 to 4 lere 22/7 lere 6.4 lere c 6.4 into 10 power minus 2 c bude arrive ni 6.4 into 10 power minus 2 ko 6.60 and 10 mathaktam hapa ko yai kaim kaide but problem is v do we want ko v is 0.4 time mo gina v kay tay what is it V. Do they care to find out V? No, M lere, Z lere, R lere. Aduga KF kinetic energy puthokpa half mv square. Half into m into v square, 16. Okay, fine. So u0 v vz half mv square is equal to this tare, then v square sida half ki 2 z mathak chatkre m 10 yo khala hai, then v sita v bawdi kem kaidre v dagi na acceleration. What is the magnitude of this acceleration if the kinetic energy of the particle becomes equal to this? And I have let me solve this from another perspective. Same question, another perspective from the solve to things. Makada engine development. Sorry. See engine development. Okay, yeah. So, CGC, another perspective from the Tozi. Auna moina kedoba, zikisida kwena sida toning izi. CGC matak takrage ka. Si kitang matak sakatke. Si sinaji matak tamge. Si mayam si kakrasi ka. Sida lal zilan talk to bani, so I'll see that later ka matam. So azik kaida we have the change in kinetic energy. The total work done according to work energy theorem, total work done is equal to change in kinetic energy never. Change in kinetic energy never ka. Now total work done di kaino have the m b square by r plus harga m a ka force to ka tangential force to aduga ma ka yare. Okay, fine. So into harga distance, so distance kaino again tangential force. What is the magnitude of this acceleration? And I have an of the if the kinetic energy of the particle. So ma into 2 into 2 pi r cinema is equal to half mv square. Aduna sigi question ji khochalo ko. Aduga we have the m set cre m lonja cre, and then moina zi kedawa v zi I already put okre ka. Aduna we r di kano r di 6.4 centimeter natra. So aduna c sidagi 2 to 4 pi r ka. Do really sumain tausi a ne ba moi pa mi c tangential acceleration ne at ne ba si. Ana CGC kaitani have the asagi half mv square half into m with the v is 6.4 centimeter. 6.4 into 10 to the power minus 2 into again 6.4 into 10 to the power minus 2 half v square. Again minus amukong ito is a it's not worth it. So minus you can't do on half mv square by r half mv square minus v square by r get divided by 4 pi r. 4 pi r. There we go. So aduna
sir,
yes.
moigise 2 hapakpa kaubo oidini moigise se moina soibo oidini. 2 hapaktre adudugini moigise. Mathakda numerator de 2 yaugadawnebako. Adudo yaudabagi oidini.
Numerator de 2 yaugadawnedi moigi solution dara.
Oh, sir. Direct ꯃꯣꯏꯅ ꯁꯤꯒꯤ ꯁꯣꯂꯨꯁꯟꯁꯤꯗ ꯀꯦꯒꯤ ꯚꯦꯂꯨꯁꯦ ꯁꯣꯜꯕ ꯇꯧꯗꯕꯤꯗ ꯑꯗꯨꯝ ꯄꯨꯂꯞ ꯑꯣꯏꯅ ꯊꯝꯖꯜꯂꯦꯗꯅꯀꯣ
Yes,
ꯑꯗꯨꯗ ꯑꯃꯨꯛ ꯁꯥꯗꯣꯛꯄ ꯀꯥꯟꯗ 2 ꯋꯥꯠꯂ ꯃꯊꯛꯀꯤꯗꯤ ꯅ꯭ꯌꯨꯃꯔꯦꯇꯔꯗ ꯁꯔ 2k ꯑꯣꯏꯒꯗꯕꯅꯤ sir.
2kf ꯑꯣꯏꯒꯗꯕꯅꯦ ꯍꯥꯏꯔꯣ?
2k by ꯑꯗꯨꯗꯣ ꯁꯣꯏꯕꯒꯤ ꯇꯥꯏꯞꯇ ꯇꯧꯋꯦ.
No, 2kd ꯑꯣꯏꯔꯣꯏꯌꯦ. 2k ꯀꯩꯗꯧꯕꯩ ꯑꯣꯏꯒꯗꯣꯏꯅꯣ? ꯍꯥꯏꯕꯗꯤ kinetic energy change in kinetic energy ꯅꯀꯣ kf minus ki ꯗꯨ 0 ꯑꯣꯏꯖꯈ꯭ꯔꯦꯅ kft ꯁꯤ ꯑꯗꯨꯝ ꯂꯩꯖꯔꯦꯅ divided by ꯍꯥꯏꯔꯒ ꯁꯤꯒꯤꯁꯤꯗ ꯃꯣꯏꯅ ꯁꯤꯒꯤ 4 pi rm ꯁꯤ ꯀꯥꯏꯗ ꯂꯥꯛꯏꯅꯣꯕꯨꯗꯤ ꯁꯣ ꯇꯧꯗ꯭ꯔꯦ but 4 pi rm ꯗꯨ ꯇꯥꯕ꯭ꯔꯥ ꯌꯦꯡꯕꯗ 4 pi r yes m ꯗꯨꯗꯤ ꯑꯩꯅ ꯀꯩꯅꯣ ꯇꯧꯁꯟꯈ꯭ꯔꯦꯕꯀꯣ ꯀꯛꯊꯠꯈ꯭ꯔꯦ ꯑꯗꯨꯅ ꯍꯥꯏꯕꯗꯤ ꯃꯥꯁꯇꯣ ꯁꯤꯗꯁꯨ ꯃꯊꯛꯇꯁꯨ m ꯑꯃꯁꯨ ꯌꯥꯎꯔꯝꯅꯦꯕ ꯑꯗꯨꯒꯤ m ꯗꯣ half m b square ꯑꯗꯨꯗ ꯃꯣꯏꯅ ꯑꯃꯨꯛꯀ b square by r ꯁꯤ ꯀꯩꯗꯧꯕ b square by r ꯁꯤ ꯃꯣꯏ ꯁꯤꯖꯤꯟꯅꯗꯦꯕ ꯑꯗꯨ ꯑꯣꯏꯔꯒꯗꯤ 4 pi rm ꯑꯣꯏꯔꯒꯗꯤꯀꯣ ꯃꯣꯏ ꯁꯤꯖꯤꯟꯅꯗꯦ ꯑꯗꯨ ꯑꯣꯏꯔꯒꯗꯤ ꯌꯥꯝ stupid ꯑꯣꯏꯅ ꯍꯣꯠꯂꯦ ꯍꯥꯏꯒꯗ꯭ꯔꯥ ꯀꯩ ꯍꯥꯏꯗꯣꯏꯅꯣ okay anyway ꯁꯤꯁꯦ ꯑꯩ ꯁꯔꯁꯨ ꯉꯁꯥꯏ ꯁꯤꯁꯦ ꯀꯩꯁꯨꯝꯇ ꯁꯤꯖꯤꯟꯅꯔꯝꯗꯦꯀꯣ ꯍꯥꯏꯗꯤ ꯁꯤꯁꯦ ꯇꯁꯦꯡꯅ ꯁꯤꯖꯤꯟꯅꯒꯗꯕꯗꯤ ꯅꯠꯇꯦꯕ ꯑꯗꯨꯅ ꯁꯤꯒꯤꯁꯦ ꯂꯧꯊꯣꯛꯑꯒ ꯀꯣ ꯃꯣꯏꯅ ꯇꯧꯔꯤꯁꯤ ꯁꯥꯏ ꯍꯥꯏꯔꯛꯀꯦꯕꯀꯣ ꯃꯣꯏꯅ ꯇꯧꯔꯤꯁꯤ ꯁꯤꯁꯤꯅꯦꯕ ꯑꯗꯨꯅ half mb square ꯁꯦ ꯁꯤꯁꯤ ꯑꯗꯨꯗꯤ 4 pi rm ꯇꯥꯔꯦ ꯍꯥꯏꯇꯥꯔꯦꯀꯣ ꯑꯗꯨꯅ mm ꯗꯨ ꯁꯔꯅ ꯀꯛꯈꯤꯕꯒꯤ ꯀꯩꯒꯨꯝꯕ mm ꯁꯤ ꯀꯛꯑꯝꯗꯕ ꯇꯥꯔꯒꯗꯤ ꯁꯤ ꯑꯗꯨꯝ ꯇꯥꯗꯣꯏꯅꯦꯕꯀꯣ ꯑꯗꯨꯅ ꯁꯤꯗꯩꯗꯤ ꯀꯩ ꯇꯥꯔꯅꯤ ꯍꯥꯏꯕꯗ ꯑꯩꯈꯣꯏꯅ half mb square ꯁꯤꯗꯤ ꯗꯥꯏꯔꯦꯛ ꯃꯣꯏꯅ ꯄꯤꯔꯝꯃꯒ ꯑꯗꯨ ꯑꯗꯨꯝ ꯗꯥꯏꯔꯦꯛ ꯑꯗꯨꯝ ꯊꯝꯕꯤꯕ ꯍꯥꯏꯇꯥꯔꯦ 8 into 10 to the power minus 4 then 4 into pi दुदी कहीं 22 by 7 आएगा into r दुदी कहीं 6.4 into 10 to the power minus 2 दो मतलब 10 square and half again and then m दी कहीं 10 gram दो 10 into 10 to the power minus 3 दो मतलब 2 and half again so mine ले का अदुना 4 2 r 8 so 7 to 14 2 जिनों का के 11 का so adu ergadi sigi 10 to the power minus 4 ga 10 to the power 3 ga di minus 10 lere minus 10 duna hadi sorry minus 1 lere minus 1 duga 2 ga di plus 1 lere plus 1 du plus 1 duga di chakre ba siga plus sat minna gre ba ko aduna kedoni have the ccd 64 ko so do the 70 by araga 704 haita 70 by 704 nebuka which is approximately equal to 70 by 704 adudi 0 point number tam si sumai la ni ka adudi even 1 bobo phangdre 0 point 0 point haraga si yadre na 0 amaga hapani 0 la ni adudi 9 la ni so 7 9 63 9 4 36 so sumaito so approximately equal to 0.1 meter per second square na sumaina taga do yung moigis so yeah bro ma'am sige za habidi sige Workdone si kaino habida mass into acceleration in a force lay jare na si ko this is force and this is displacement never gyan ta hoda bra mana si the second revolution habini na ko adugin kanam to kumukti si kay gino
Tayo, sir.
Lakshmi ko me Niha, Nivya, Udagi, Sunanda, Tabra. Okay, fine. So, adudo ni ko, sumay 70 by 704 taba. Mamangi duda kamay shoy no tang yenge. Mamangi duna kayo. Mamangi so 70 by harga 70 by kayo. 70 by 35 tabra. Something. Sida 2 mo alam may type to 70 by 22 into 16 never go. Sida na kay. Sida na 70 by okay 6.4 ga 16 ga kakhraba ka 8 into 만나범 디 투에버 아시주 란베 찬시 숭레이디 레이터버네요 시수 좀디 좀도네요 가이드 소이노 22 by 7 6.4 64 거 amtang yengi ko sir amtang cross check tawge sisu lanbam di song thokte aduna ai amtang cross check tawge ko aduna sigisi aina zi kaigumba 44z adum kedoba ya 4 into 4 thamage ko and then 7 thamage 2 into 2 the 4 tare then sida 22 thamage and 64 gi si aina kedoba direct adum 6.4 moin centimeter pyramid 64 thamaga di 10 to the power minus 2 do the 10 to the power 2 thamage ko 10 to the power minus 2 do ade amka point to amok keno toge 10 amaga hapani na ko aduga amuka math c minus 2 je mathak pukhat pa yung 10 square yung la ade amuk si point je keno toropagi makada 10 square lani 10 square ka khre tare ko aduna sigi sida 4 ga ka khre aduna 2 to 4 2 11 22 ko aduga mathangdadi kai leire habada sigi 2 sina ka gadi 2 236 224 236 224 adudi 70 by 11 into 32 chatpa masagi dudana 70 harga 11 into 6.4 chatpa ko adudi kainom di kheti kenare kai de kenai no have the one something half mb square 4 into 22 into 6.4 4 into 22 into 6.4 sibudi yare mataktana kai 4 into 4 leba ko 4 into 4 16 neba ko and mogi sidana 8 leba ko and 2 ama kenaba 2 ama di chenare 2 ama senai si sina 2 add 2 pi r loba ko aduna sida di h4 gibra 2 into 2 pi r 2 into 2 pi r cg av is again 8 to 16 16 10 to the power minus 4 is puthara di 10 square 100 16 by 100 di 4 by 10 4 by 10 di 0.4 0.4 square di 0.4 into 4 8
The formula gi 2 mawat male twice a sin na ke but
oh sida 2 wala me patra haidi 2 pi r ne ko sigi 2 pi r jim la na second revolution gi si formula gi 2 wala me ba aduna ne ngasai dei tenai hadik ta ni chamana ne answer du di si yan da ko as unnecessary ngasai dei yung sida anyway so aduna kedo we have the cgc sigi 2 zina mathaki 2 zika aga ko aduga tarne du re di adudi aina sigi 64 da kakpa zika aroi karoi 64 da karoi ko aduga azik keno tauge sum haidi sir na keno tau haidi sir na aham do holi do du kemte landi have the proof tawning way one haidi kuina number do tu ama walam bagi formula sinjan mo soibe ki khatangi ne ko aduga kemte conceptually kem landi ko aduna maru oi si kanoi conceptual clarity du ne ko aduna mithak posiju mithak ta posiju yamna maru oi mithoi dabani aduga conceptual clarity leitragadi adum mithake thoige adu dum chaya ara so aduna cca is kakke forum ga kakre 2 zina sida ka di sitare then sigi 2 zina ka di sida 11 tare so 70 by harga si 10 square si kakre ka aduga 64 11 into 64 to masai ta dai swaina so 11 into 6.4 je kena to thori adi 70 by 704 ta jani masana ko kaino ai matamda masai gi si 4 tare 6 ko 6 plus 4 di 10 6704 tare si ji makha into to then mathaki ji into to the 70 ji da 10 square na sumain to roga hapa ko 7 10 square ma mu handle da to is 10 square ji mathaka khale na ko si point ni ji makha da 10 square hape na ko the si 10 square ji kai line सी tan square ji lakpam leite ko aduna kaidawi hasa ji tan square ji lakpam leite si kakkadam ne aduna 70 by 704 tagada 70 by 704 ko aduna 70 by 704 di 0. Nasai gitu kai tagiba 0. Something 0.09 tagiba ko 0.09 which is approximately equal to 0.1 matam ban sang thokri sida gyan di tabra me
ताए सर
tai ko okay sir gi kwai sir na tali sumaina mit thakpadagi matam sang jcg ai human being amni na ko ata sometimes yaurai ko oza oiraga ju hai tare aduna noi da ju sir na hining ji kai na da noi question yari ge yam hanjan jan practice to wai do sigi pot se exam an ga thok tan ne ko sir wai di exam tha do leitram ni na singuma minor mistake si yam kan na khanjalu de hai tare but noi di exam tha do pe kha nung so na ti le ri ya ro ko adu gi ni hanjan jan practice to wai do anyway now let's proceed guys question number kya hai where is it so already 9:30 tare class question badi yare do question ama ni dang ga tawar galo shalasi so hajiki do karam mana point to ida si jira mane okay question number 9 jing am gadre ne bullet ki je a bullet of mass 10 gram lifts a rifle at an initial velocity of this and strikes the earth at the same level with the velocity of this. The work done in joule for overcoming the resistance of air will be. So sising am gadra sidi am like half mv square minus half mu square toro aduga dum tare yeah bro kyan tade
ताए सर
like so sigi si kena to gudraba noi ngamadraba sunanda ga lakshmi ga ngamadra niha nibia sanjana ngamadra hairo cheta ko maji ai ko sanjana
औ सर गमनी
ngamani niha mat
गमनी सर
ngamani ko okay fine sanjana keno ga sunanda ga lakshmi ga ngamadra
औ
okay yeah fine fine adudi sumain to si ko question amtang di to se ko adu lo shalasi a particle moves from this to this when a force is this how much work has been done by the force sigi question number 10 ji di noi ngamgadra sisi moina pg ko point a ga point b ga sidagi nang na sisi difference lo ga position vector puthoni id delta r id f dot ds ne ba so ds to c ani ji difference na ta r ni f to the c le dot product lo ga work done the thola ni ai ni ko question number 10 ji haigadra hairoidra tawjira tawrisira saja hairo
आईनी सर
lakshmi ga sunanda ga di
ओ यार
question okay fine so next is 11 a uniform force of this Newton x on a particle of mass 2 kg hence the particle is displaced from position this to this work done yeah I see chamane a body moves a distance of 10 meter along a straight line under the direction of this if the work done is this then the angle between the force and direction of motion of the body is this is question number 12 12 13 14 jida no apa among kalo 12 13 14 jida question number 12 13 14 da pam am khalo du ngasi class lo shala ji ko so ja ino ro question number 12 si loina ma hai redra 12 se
Hayroye sir.
Hayro ya.
Workdone sir.
Job doors ya. Okay, fine. Yeah. Okay, fine. So question number 12, the higher is a body moves a distance of 10 meters along a straight line under the action of 5 Newton force. Okay, if the work done is 25 joules, then angle between the force and direction of motion है. Very simple. Force is F से 5 Newton. Again, okay, I won't write this as vector. D moina magnitude and F is equal to 5 Newton. Then work done, W is in a pyramid 25 joules pyramid. And then distance in a pyramid S in a 10 meter pyramid. W is equal to Fs cos theta neva. W is equal to 25, F na 5, S na 10, 50 or the cos theta, cos theta, the cos theta is cos theta is equal to half, or theta is 60 degree tadro. Can tadro was is an hour ba?
Oh, yani sir.
Yam laile amra. Adudi yaradra. Okay. So Nivya, Niha, Sanjana, Sisi Gyanta Obra.
Oh, sir, tay.
Okay, fine. So anyway, for Edudi Nasigi Dika, Sisida Nasigi work energy power work done gi basic definition the base of question hole work energy theorem hole kinetic energy ki no angam bagi hota law the next class da queen ke doba further the conservative force, then idea of potential energy, and then equilibrium the base of a question do the particle circular motion the base of a question ka, and then conservation of mechanical energy the potential energy kinetic energy tamamina mechanical energy is come kind of conserve when all the forces are conservative and the base of a question holaga sigi power gi ha kedoba power gi velocity gi definition the base of hola sigi chapter ji lo shalani ko. So in the next two classes akoi loinaba taurani. Okay, fine. So ma'am loinaba kino tauro ko ngasigi di sidlo shalaji ko. So stop tauro ko. Okay. Good night. Good night.